Hello friends, today let us solve some multiple choice questions based on the topic circle from class 10th. We have studied various properties of circles. In this video we are going to solve some objective questions based on those concepts. So let's start with the first question. The question is, four alternative answers for each of the following questions are given. Choose the correct alternative. The first question is, two circles of radii 5.5 centimeter and 3.3 centimeter respectively touch each other. What is the distance between their centers? So the four alternatives are given: 4.4 centimeter or 8.8 centimeter, 2.2 centimeter, or option D 8.8 or 2.2 centimeter. So we have to choose the correct alternative amongst these four. Now for this one, we have a circle given. Now it is given that there are two circles with radii 5.5 centimeter and 3.3 centimeter. So let this circle be of radius 5.5 centimeter and there is another circle of radius 3.3 centimeter. Now if these two circles touch each other externally, then we know that the distance between their centers is equal to sum of their radii. That means, suppose this is the center of the larger circle, let it be O, and there is a center of a smaller circle, BP. Now if we draw a line segment joining these two centers, we know that the common point of these two circles lies on this line segment. So let that common point be M. Now if we have to find the distance OP, that is, we have to find the distance between the centers of these two circles, then for the larger circle radius is 5.5 centimeter and for the smaller one it is 3.3 centimeter. To find the distance between these two, we have to add these two, that is 5.5 plus 3.3, so as to get the distance 8.8 centimeter. So this is the distance between the centers of these two circles. Now in the question it is not given that these two circles touch externally. So we have to consider both the possibilities. Either they are touching externally or they are touching internally. So if they are touching externally, then we get the distance between these two 8.8 centimeter. And if these two circles touch internally, then to find the distance between the centers of the circles, we have to subtract the radii, that is, we have to subtract the smaller radius from the larger one, that is, we have to subtract 3.3 from 5.5. So 5.5 minus 3.3, that's 2.2 centimeter. So this is the distance between the centers if these two circles touch each other internally. At present, we don't know whether they are touching externally or internally, so I have to consider both the conditions. If they are touching internally, then the distance between their centers is 8.8 centimeter, and if the circles are touching internally, then the distance between their centers is 2.2 centimeters. So here for this question we have two answers, 8.8 and 2.2, which is given at option D. So option D is the correct alternative. Let's have the next question. Two circles intersect each other such that each circle passes through the center of the other. If the distance between their centers is 12, what is the radius of the circle? Again, four options are given: 6 centimeter or 12 centimeter or 24 centimeter, or can't say. Let us consider this is the first circle and there is another circle. Now it is given that these two circles intersect each other such that they passes through the center of the other. So suppose this is the center of the first circle, let it be P, and there is another circle with center Q, and it is given that the distance between these two centers it's 12 and we have to find the radius of the circle. Now as diagram suggests, if we consider the first circle, for this one P is the center and there is point Q which is on the first circle. So if we consider PQ for the first circle, PQ is the radius. In the same way, for the second circle, Q is the center and for the second circle, P is any point on that circle. So again, for second circle also, PQ is the radius. And PQ is nothing but the distance between the centers of these two circles, and it is given to be 12. That's why the radius of both the circles is 12, because the distance between these two is given to be 12. So here we have the answer 12 at option B. That's why option B is the correct alternative. Let us consider the next question. A circle touches all the sides of a parallelogram. So the parallelogram must be dot dot. Is it a rectangle, or is it a rhombus, or a square, or a trapezium? So let us have the diagram. Let us have this circle. It is given that this circle touches all the sides of the parallelogram. So let us consider this as a parallelogram. We have to decide whether this parallelogram is a rectangle, or a rhombus, or a square, or a trapezium. Now suppose this is a circle, and as it touches the sides of a parallelogram, let us name this parallelogram as parallelogram A, B, C and D. Now if we consider two line segments drawn from A, these are the two tangent segments drawn to a circle. And we know that a tangent segments drawn to a circle through an external point are congruent. So if this is x, then the another tangent segment must be also x. In the same way, there are two tangent segments drawn from B. Let their lengths be y. Suppose the point of contact as M. So AM is x and MY is y. So the length of segment AB is x plus y. And as a quadrilateral ABCD is a parallelogram, if AB is x plus y, its opposite side CD must be also x plus y. So length of segment CD is x plus y. Now as we can observe here, the tangent segments drawn from point A, the length is x. Let the lengths of tangent segments drawn through point C are also x. And in the same way, tangent segments drawn through point D be y. So BC again can be calculated as x plus y, as these two smaller tangent segments are there with length x and y. In the same way, AB can be also calculated by x plus y. So as we can observe, we have got all the four lengths of this quadrilateral. It is AB is x plus y, BC is x plus y, CD is x plus y, and AD is also x plus y. So in short, all the four sides of this quadrilateral are congruent. And we know that if a quadrilateral is there with all the sides congruent, then that quadrilateral is called as a rhombus. So amongst all these four options, we have the answer rhombus, that is alternative B is the correct alternative. Let's have the next question. The length of a tangent segment drawn from a point which is at distance 12.5 centimeter from the center of a circle is 12 centimeter. Find the diameter of a circle. And options are 25 centimeter, 24 centimeter, 7 centimeter or 14 centimeter. Now to get the answer of this one, we have to draw a diagram firstly. So let us have this circle. So let us consider this circle with center O. Now it is given that there is one point which is outside the circle, as the length of tangent segment drawn from a point is given. That means the point must be in the exterior of a circle. So let the point be P. Now it is given that the length of the tangent segments. Now we have to draw a tangent segment from point P. So let us consider PQ be the tangent segment, and the length of this one is given to be 12 centimeter. So the length of tangent segment is 12 centimeter, and a point which is at a distance 12.5 centimeter from the center. Center is O, and the distance of point P from center O is given to be 12.5 centimeter. So this is given, and from this one we have to find the diameter of this circle. Now to get the answer of this one, we have to join O and Q. Now as we can see here, PQ is the tangent, OQ is the radius, and we know that tangent is always perpendicular to the radius. So angle OQP must be 90 degree. So triangle PQO is a right angle triangle. So in that triangle we can use the Pythagoras theorem, and by that we can have hypotenuse square, that is OP square, is equal to remaining two sides are PQ square plus OQ square, and OQ here is nothing but the radius. Now we have OP. The length of OP is 12.5 centimeter. So we will replace here OP by 12.5, that's square, is equal to PQ is 12, which is the tangent segment, that's square again, plus OQ square as it is, as we have to find OQ. If we make a square of 12.5, it will be 156.25, that is equal to 12 square is 144 plus OQ square. Now if we take 144 to the left hand side, we will have 156.25 minus 144 is equal to OQ square. Now if we do this subtraction, we will get 12.25, that is equal to OQ square. And if we take square root on both the sides, the square root of 12.25 is 3.5 is equal to OQ. So OQ here, that is the radius, is 3.5 centimeter. But we are asked to find the diameter of a circle. Now if the radius is 3.5, then from that we can find the diameter, as diameter is always double the radius. So if radius is 3.5, diameter must be its double, that is 7 centimeter. And we have this answer at option C. That's why option C is the correct alternative. Let us consider the next question. If two circles are touching externally, how many common tangents of them can be drawn? 1, 2, 3 or 4. So for this one, let us have the circle, and there is another circle which is touching externally to the first one. So let us consider the smaller circle which touches the first one externally. Question is asked, how many tangents, common tangents, can be drawn to this circle? We may wonder that as there is only one common point, as these are externally touching circles, we can have only one tangent which passes through the common point of both of these two circles. But it is not the case. If this is the first tangent which is common for both the circles, now we can have another tangent which touches these two circles. So this is the second tangent, and if we have the third tangent which again touches these two circles like this one. So in all we have 3 tangents which are common for both of these two circles. So here only one common tangent is not there. If there are two circles which are touching externally, then we can draw 3 common tangents for them. So the correct alternative is option C, that's 3.